Welcome back to I Am One, everybody. Today's topic 2.2.2. We're continuing. This would be pretty much part three. So now we're just identifying again contextually what M and B are, and pretty much knowing that M represents a rate of change. So it says other rates of change. So the slope of a line can represent many things. In this lesson, you concentrated on situations with the rate of change of a line. The slope represented speed, right? So if you guys already watched part one and part two, you remember we were talking about the speed of the kids riding in the tricycles, which was pretty much meters per second, right? And then when we're graphing that, we're talking about having time was in our x-axis, and then the distance in meters was in our y-axis. All right. So that's how pretty much we get this rate of change. And again, that's always your slope when we're talking about that. So we're going to be talking about, it says, however, rate of change can represent many other things besides speed, depending on the situation, right? So again, we're relating this back to the four things that we have in mathematics, right? When we try to describe something, we have a situation, right, which we just saw pretty much. We also have a graph, right? We did that when we were trying to figure out how fast the kids were traveling, and then pretty much when they crossed the line of the goal line. Also an equation. And again, we also have a table, right? And again, all of these relate to each other as well. So it says part A, for each graph below, explain what real world quantities the slope and y-intercept represent, and then calculate the unit rate of each situation. Be sure to include units in your answer, right? So the slope here, again, if you guys look at the first graph, you look at the x-axis, and that's years since planting, right? And it says height of a tree in feet. So we're comparing two quantities here. We're comparing the height of a tree in feet, right? And then we're comparing it to time in years, pretty much, all right? So we want to find pretty much the slope. The slope blank represents the rate. So let's figure out the slope again. To do that, you guys can make your slope triangles. So if you start off at the y-axis, remember that's pretty much always going to be your initial value. And the value for that point is always 0, comma, and then wherever you're at. And in this case happens to be positive 4. So from there, we're going to go up, right? We're going to go up 10 to get to 14. So that's our change in y. And then we're going to go to the right. If you notice, we're going from 0 to positive 5. So our change in x happens to be positive 5. So the slope, which happens to be, again, delta y over delta x, so 14 over 5, says represents the rate at which the tree grows in feet, right? How much the tree is growing. The tree grows in feet every year since planting. And then the y-intercept of the graph represents the what. So again, if you guys identify it here, right, our initial value, it says years since planting. So our y-intercept would be the height of the tree when it was planted. Now let's look at problem 2 from the same sets. It says, so let's look at the graph. Again, if you guys can see, the line is going down. And then we're given 2 points, right? We're given this point right here and then that point right there. So for sure, every time you guys see your line going down, your slope has to be negative, right? That your delta y over delta x has to be negative. And then your initial value here, so let's look at, now we're looking at time in months, which is our x value, right? And then the bank balance, cash, right, dollars, is our y-axis. So now we can say that the slope, which in this case, blank, represents, again, we want to do the same thing. So you want to find the slope first. So delta y over delta x. Now, again, in the previous lessons, you guys did the formula for it, which was, again, subtract the y values. So 150 minus 130. And then at the bottom, we're going to have 2 minus 4. So 2 minus 4. And that's equal to, simplify one more time, we're going to have 20 on top divided by negative 2. So that's going to be equal to negative 10. So here, our slope, which is negative 10, represents the rate at which our bank balance decreases, right? Because it's going down per, right? Per, and in this case, we're measuring time in months, so per month. Now, if you identify the y-intercept, so we're going by tens on the y-axis. So it's going to be 170. So our y-intercept is 170. So actually should be 0, 170. So this pretty much the y-intercept of the graph represents, now if you guys think about it, it was the initial balance, right, before you started measuring this. So it was the initial balance in the bank. All right, and then question 3, we're looking at distance in miles. And then at the bottom here, we're looking at gas in gallons. So here again, you want to identify the slope. So we're going to be looking for delta y over delta x. So that's equal to, again, subtracting the y's, you're going to go from 44 to positive 88. So 44 minus 88 divided by 2 minus 4. So 44 minus 88, that gives you negative 44. And then divided by negative 2. Negative divided by a negative happens to be positive 22. So that's the slope. The slope 22 says represents the rate at which we are using gas, or yeah, pretty much like at the rate at which you are using gas, or how many miles per gallon you're getting, right? So represents the miles per gallon that makes more sense that you get for the car, right? That you get on your vehicle, right? Because when you guys get a car, pretty much they talk about like you've seen the commercials. They say like 30 mpg and so forth, right? So that means that you're getting 30 miles per gallon, and that's a rate. So it's looking at the same thing right here. So the y-intercept of the graph, if you notice, we started at the origin, right? So if you have 0 gallons, so 0, right? 0 gallons, so no gallons equals no miles pretty much. So if you don't have any gas, you can't travel, right? So no gallons, which means no distance traveled. And then the next one, that would be pretty much it, right? So again, the slope 22 represents the rate at which the miles per gallon you get on your vehicle. So how far you can travel per gallon. And then the y-intercept, if you don't have any gas in your car, that means you're not going to be able to travel. So here, you're traveling every 22 miles per gallon. Now, let's look at it. Says in each of the situations, would it make sense to draw a different line with a negative y-intercept? So if you guys look at pretty much at any of these, would it be possible for you to have a negative y-intercept? Like the line would start off over here somewhere at the bottom. Like on the first one, would it make sense to have a negative y-intercept? To me, it could, because you can say you planted, right? You planted the seed, and then you can measure it since pretty much since you started. So that might be a reason to make it a negative y-intercept. So probably that one. For this one, the bank balance. So I'm pretty sure that if you have a negative, like if you were to draw your line down here, if you have a negative bank balance, then you're not going to be able to take out money. So for sure, it doesn't make any sense to draw a negative line there. On the next one, since here, like the x-axis represents gallons and then distance in miles, it's not possible for you, like it doesn't make any sense for you to have anything besides starting on the origin, right? Like here, like going on the negative side means you traveled in the opposite direction, which makes no sense, right? So you can't go back in distance. So for sure, just in the only one that makes for you, like that you could be possible for you to draw a negative y-intercept, would be on the first situation, right? On part one, where you can start measuring since you planted, right? From seed, where you can measure the plant from seed, starting from seed. And that would be pretty much the having a negative y-intercept, right?